Hi guys, today is section 6.1. So it says for number 1, Green's Grass Guaranteed charges business a flat fee of $30 plus $80 per acre for lawn mowing. For residential customers who may have more limited budget, Jim Green needs to determine the size of the yard he could mow for a particular weekly fee. Number 1, the cost function F is, and it's written here, C equals 30 plus 80A, where C is the cost to mow A acres. Should be familiar with that function. We've been working with it quite a bit. Use the function to determine what part of the acre Jim could mow for each weekly fee. So here's what we have. We know the cost, and we're going to figure out how much he can mow, how many acres he can mow. Is it more than 1, less than 1, or what fraction it is? So I can walk through the first one with you. The cost is 60. Of course, I'm going to subtract 30, divide by 80, and we can simplify that because those are both divisible by 10. So he can mow 3/8 of an acre. This is for part A. 3/8 of 1 acre. Go ahead and do B and C. Figure out how many acres. Pause the video. For part B, you should have gotten 5/8. And for part C, 1 acre. Okay. To make a profit and still charge a fair price, Jim needs a function for calculating the maximum acreage that he can mow based on the amount of money a customer is willing to spend. What are the units of the domain and range of the cost function in item 1? So domain is input, range is output. So the input is the acres, and the output is the cost. We need units, so dollars. Okay, so before we go on, if I were to give you this equation, would you rather me give you C? Or would you rather me give you A? What would be easier? Well, in this equation, it's usually easier if I give you a bunch of A values, a bunch of acres, and you can figure out the cost. But notice that's not what happened here. I gave you the C value, the output value instead. So this lesson is about inverses, and this is going to help us flip that. So if I give you an equation where A seems to be easier, I'd rather have a list of A values to plug in. What you can do is if I give you a bunch of C values, you can find what's called the inverse, and then that will be your input value, which you'll see here we'll do in just a second. So number 3, solve the function, which were listed right here in item 1 for A in terms of C. So it has C equals, we want it to be in terms of A. We want to get A by itself. So to get A by itself, we're going to subtract 30 on both sides. Divide by 80. Now this function, wouldn't you rather me give you the C value instead of the A value? We have just found the inverse. So now the input is now the output. Number 4, write the function from item 3 using function notation, where G is the acreage function. So function notation is G of something. What's our variable? It's C. So C minus 30 over 80. What are the units of the domain and range? What's my input? My input is now C, which is the cost in dollars. And my output is A, the number of acres. So the functions, this function here and the original function are very similar. One has C by itself, one has A by itself, depending on which you'd rather have for your input and which you'd rather have for your output or your range. Okay, we're going to jump to number 7. Use the appropriate function to evaluate each expression. Let's go ahead and write the functions again. So the f function was 30 plus 80a, and the g function was c minus 30 over 80. Okay, so let's do the first one. It says g of 60, so I go to the g function and I plug in 60. This means this is my input, so I'm plugging in 60 here. So 60 minus 30, all of that over 80. So that's going to be 30 over 80, which is 3/8. For the next one, make sure it doesn't look like 3/18, 3/8. For the next one, you are going to plug in, let's change colors here. You're going to plug in 60 to the g function, which we've actually just done. We already figured out that. That's 3/8. Once you get that, that's the inner function. Now you plug 3/8 into the f function. So let's do that. So what is 80 times 3/8? 30. Okay, part C, f of 2, go ahead and plug in the f function, plug in a 2. You should get 190. And for part D, notice it's a compound or a composition. So first you're going to find f of 2, which we already did in the previous problem. F of 2 is 190. So now I plug 190 into the g function. Be careful if you type this into your calculator. Watch real quick. This will give you an error if you type 190 minus 30 divided by 80. That will not give you the right answer because, take a look here, all of this is being divided by 80. And when you type it this way, only the 30 is being divided by 80. So you must type all of the top divided by 80. Make sure you're doing that correctly in your calculator. Your answer should be 2. Now, number 8, we're going to interpret these answers. It says, interpret the meaning of each expression and its corresponding value in item 7. Be sure to include the units in your explanation. So for A, we got 3/8. What does that mean? Explain and use units. Okay, so your answers are for 8, your interpretations for part A. You could mow 3/8 of an acre for $60. Part B, it costs $60 to mow the number of acres you can mow for $60, which sounds kind of confusing, but that's because it's a composite function. We put a number in, and then we put it into something else. We actually got 60 again. Part C, it will cost $190 to mow 2 acres. And part D, you can mow 2 acres for the cost of mowing 2 acres. Again, it sounds confusing, but that's because we did a composite function. So think about what's happening first, f of 2, so the cost to mow 2 acres, and then g of 2, it's how many acres you could mow for that cost, which happens to be 2. All right, number 9. In general, what is the result when you evaluate f of g of x and g of f of x? So because these two functions, let me go back to 7, because these functions are inverses. When I take a number and put it into G, and then I put it into F, look what happens. When I took 60 and put it into G, then put it into F, I got 60. When I took 2 and put it into F and then put it into G, I got 2. I get what I started with. So if these are inverses and I do the composite function, I will get what I started with, what my original input is. So how will that work here? If I input X to the G function and then input all of that to the F function, my output will be X, what I started with. Same for this one. If I did G of F of 7, I would get 7. If these functions are inverses, that will always happen. Okay, so what do the answers in item 7 suggest about F and G? The functions undo each other. Okay, so they are inverses, that's what happens. Just like if I have $10 and I add 7 and I subtract 7, add and subtract are inverses. So they essentially undo each other and I get what I started with. That's what happens when you're working with inverses. So the last part today is going to be a little bit more with inverses. So it says, oh, sorry, there's a little blurb here we should go through first, and we'll talk more about this part tomorrow. Two functions, f and g, are inverse functions if and only if, and this is what we just talked about, if these are inverse functions, whatever you input, that is what you're going to get out. So f of g of x equals x, and g of f of x equals x. Again, we'll talk more about that tomorrow. The function notation f inverse denotes the inverse of a function f and is read f inverse. It looks like f to the negative first power. It is not. It just looks like that. It's called f inverse. Item 6 showed the domain of a function is the range of its inverse. Likewise, the range of a function is the domain of its inverse. So when I had my functions, I'll just call them function A and function B. I don't remember the letters. My input was acres. My output was dollars. When I did the inverse, now I input dollars and I output acres. This is what they're talking about. The domain of one is the range of the other. And the range of this is the domain of this one. That will always happen with inverse functions. So how do we find an inverse? This is going to walk us through the steps, and then we will do 4 examples. So if I give you a function and I say, find the inverse, here's your steps. First step, let y equals f of x. So originally it says f of x. You're just going to change that to a y. Your next step is to interchange x and y. So notice here's y and here's x. We're going to exchange those or flip them. The next step, which takes the longest amount of time, is to solve for y. So if I have this and I want to get y by itself, you can see they added 4 to both sides. And then to get y by itself, they divided by 2 on both sides. So dividing by 2 here gives you y, dividing by 2 here gives you this. Finally, change your y into what we call inverse. Okay, so that is how you do it. You flip x and y, and you solve for the new y. Let's practice. Find the inverse of each function. Step 1, change f of x to y. Step 2, exchange x and y. So wherever you see an x, put a y. Wherever you see a y, put an x. Now we have to solve for y. So how will I get y by itself? I'll subtract 8 on both sides. Now I will divide by -3 on both sides. And finally, I need to change this y into F inverse. And that's the inverse. A couple of you may be familiar with, a lot of times in math, we don't leave the negative in the denominator. So I prefer to write it like this. Put that negative out front, or apply it to the top. So that would be negative x plus 8. Either one is fine. Let's try B. Change this to a y. Next step is to flip x and y. Now we solve for y. This is the longest step. Normally we add and subtract first, but you don't want to get rid of the 12 because if you notice something's being multiplied by it. You could distribute. I would just get rid of the 1/4 by multiplying both sides by 4. Now you can get rid of the 12 by subtracting 12 on both sides. And then before you circle your answer, you want to change the y into inverse. That's g this time because that's what we started with. So this is the inverse. This is the g function. This is the inverse function. Okay, why don't you pause the video and try C and D? Here are your answers. Actually, let me just go through all the steps. So this is going to be x, I'm going to switch it with y. Now when I solve for y, I get this. To get rid of the 2/3, I'm going to multiply by 3/2 on both sides. So you can write it one of two ways. You can write 3/2 x plus 5 equals y, or you could write 3x plus 15/2 equals y. Whichever you pick, make sure then you write inverse. And for the last one, change it to a y, flip x and y. So what goes first here? I would multiply by 6 first on both sides. Then add 2 to both sides. Then divide by 3. Again, there's a couple ways you could leave your answer here. You could leave it like this. Or because they're both divided by 3, 6 divided by 3 is 2x. So this or this, but then don't forget to change it from y back to inverse. The letter we used here was j of x. So one is just with the 3 denominator, and one I broke the 3 into each separate for each part in the numerator, and then I did that because it simplifies 6/3. But either one is fine. You don't need to write both. And that is how you find inverses. So you're ready to begin your homework.